Bismillahirrahmanirrahim. Hello students, welcome to another video. This is Hamza Noor from Aero Education Network, and in this video I'm going to solve a few questions for International A-Level Edexcel P2 Pure Mathematics 2, and the topic is particularly chapter number 3, Exponential and Logarithms. Okay, we are doing some past paper questions for this topic, and first of all we have October 2022 question number 10. So the question says that given that a is equals to log with the base 2 argument 3, the requirement of part 1 is to write in simplest form in terms of a. The requirement of part a is log with the base 2 argument 9. Okay, so first thing first, what we know the fact is that in place of 9 we can write 3 square. Okay, so this is exactly the same thing as saying log with the base 2 argument 3 squared. Okay, and then according to the power law, this power can come down over here. So this means that 2 is multiplied by log with the base 2 argument 3. Okay, and in this, exactly in this place, log with the base 2 argument 3, we can write a. Okay, so we can write exactly a over here. So this means 2 times a. This is the requirement of part 1, a part. After this, we have part B, which says that log with the base 2 argument root 3 over 16. So here we can simply use the quotient law of logarithms. Okay, so in place of under root 3, I can write 3 raised to the power of half, and in place of 16, I can write 2 raised to the power of 4. And then according to the power law, I can say that this power half can come over here. Okay, it can come down. So half is basically completely multiplied by log with the base 2 argument 3. Okay, and the power 4 will come over here in the same way. And then we will subtract, 4 multiplied by log with the base 2 argument 2. And as you are aware of the concept that log to its own base is equals to 1, meaning when the base and argument are the same, so outcome of this thing is equals to 1. Okay, this is exactly the same thing as saying that a is the base of the log and argument a, so this is also equals to 1. Let's say we have 3 as the base of the log, argument 3, this is also equals to 1. Okay, so the concept is that log to its own base is equals to 1. So in place of this expression, log to its own base, meaning when base and the argument are equal, so I can say that this whole thing is exactly equals to 1. Okay, so in place of log with the base 2 argument 3, we can exactly write a. Okay, as per the condition of the question. So this means that half a minus 4 times 1, which is half a minus 4. Okay, so this was the requirement of part B. All right, and now let's move on to part 2. So the requirement of part 2 is to solve this equation 3 raised to the power of x multiplied by 2 raised to the power of x plus 4 is equal to 6, and we need to give our answer in simplest form in terms of a. And as you are aware that a is equals to log with the base 2 argument 3. Okay, so here I have discussed this part 2 in two approaches. Okay, so first of all, we have this equation 3 raised to the power of x multiplied by 2 raised to the power of x plus 4 is equals to 6. And since we want our answer particularly in terms of a, okay, and here the base of the logarithm is 2. So in the first step, I can say that introduce log with base 2 on both sides. Conceptually speaking, we can introduce any base of log, but particularly we need our answer in terms of a over here in this question. We need to solve this equation and we need to find the value of x in terms of a, where a is basically log with the base 2 argument 3. Okay, so as per the requirement of the question, I can say that introduce log with base 2 on both sides. Okay, so log with base 2 and the complete argument will be 3 raised to the power of x multiplied by 2 raised to the power of x plus 4. And here we have log with the base 2 argument 6. Okay, and since these two arguments are being multiplied together, so I can use the product law of logarithms, and I can say that log with base 2 argument 3 raised to the power of x plus log with base 2 argument 2 raised to the power of x plus 4. This is basically the product law of logarithms. And this whole thing is equals to log with base 2 argument 6. Okay, and in place of 6 I can write 2 times 3 as well. Okay, in place of 6 I can write 2 times 3 as well, so I've just mentioned this thing in the very next step. Okay, so according to the power law, here the power x can be multiplied over here, so x will be multiplied by log with the base 2 argument 3 and then plus, and this power x plus 4 will come down over here. Okay, so I can say that x plus 4 is completely multiplied by log with base 2 argument 2, and this whole thing is equals to log with base 2 argument 2 times 3. In place of 6 I mentioned 2 times 3 intentionally, because I need a specific form. I need to give my answer in terms of a specifically. Okay, so intentionally in place of 6 I have mentioned 2 times 3. So now, as you know that log with base 2 argument 2, this will be equals to 1 because log to its own base. So in the next step, I can say that x multiplied by log with base 2 argument 3 plus x plus 4 completely into 1 is equals to, according to the product law of logarithms, I can say that log with base 2 argument 2 plus log with base 2 argument 3. Okay, and now in place of log with base 2 argument 3, I can write exactly a. So x multiplied by a plus x plus 4 is equals to 1 plus a. So now all we need to do is just rearrange the terms and make x the subject. So ax plus x is equals to 1 plus a minus 4. So taking x common multiplied by a plus 1 is equals to a minus 3, and therefore x is equals to a minus 3 divided by a plus 1. This is supposed to be our answer. This is the requirement which we are looking for. Okay, so we needed to express our answer in terms of a, where a is basically log with base 2 argument 3. Log with base 2 argument 3. So now let's move on to the alternative working as well. For this part, alternatively, I started with this equation, and first I expressed this in a basic index form. The basic index form, which is y is equals to a raised to the power of x, where a is basically the base and x is the power or the index, you can say. So when a basic index form is converted into a logarithmic form, so the base of the index form becomes the base of the logarithmic form. Okay, so basically the idea behind this is that the basic index form, which is y is equals to a raised to the power of x, so a, which is the base of the index form, this will become the base of the logarithmic form, and I can say that log with base a argument y is equals to x. Okay, so first I made sure to rearrange the equation into a basic index form and then convert it into a logarithmic form. And then I used the change of base law in my further working in order to, you know, find the answer according to the requirement of the question, which was in terms of a. Okay, where a was basically log with base 2 argument 3. Okay, so first thing first, starting with this, 3 raised to the power of x is multiplied by 2 raised to the power of x plus 4 is equal to 6. So according with the laws of indices, in place of 2 raised to the power of x plus 4, I can write 2 raised to the power of x multiplied by 2 raised to the power of 4. As you know, the fact that, a raised to the power of m plus n is exactly the same thing as saying a raised to the power of m multiplied by a raised to the power of n. This is the basic rule of indices which you are studying since O-level maths, O-level and IGCSE maths. And you have also studied these concepts in P1 as well. Okay, so in place of 2 raised to the power of x plus 4, we have mentioned 2 raised to the power of x multiplied by 2 raised to the power of 4. So now the terms which are, related with x, meaning the terms which have the power of x, they are on one side of the equation, and the terms which don't have the variable x in their power, they are on the other side of the equation. So I can say that 3 raised to the power of x multiplied by 2 raised to the power of x is equals to 6 over 16, and 6 over 16 is simplified as 3 over 8. And now according with the rules of indices, I can say that 3 multiplied by 2 whole thing is raised to the power of x. As you know, according with the laws of indices, if you have a raised to the power of m multiplied by b raised to the power of m, so this is exactly the same thing as saying a multiplied by b whole thing is raised to the power of m. Okay, so I can say that 3 multiplied by 2 whole thing raised to the power of x is equals to 3 over 8, and 3 times 2 is basically 6. So we have a basic index form which is 3 over 8 is equals to 6 raised to the power of x. Okay, we have found the basic index form like this: y is equals to a raised to the power of x, where the base of the index form is 6. So this will become the base of the logarithmic form. So in the very next step, I can say that log with base 6 argument 3 over 8 is equals to x. I can also, read it like this: log to the base of 6 argument 3 over 8 is equals to x. Okay, but specifically we need our answer in terms of a, where a is log with base 2 argument 3. I need to make the base 2, not 6. Okay, so for that purpose, we will use change of base law over here. So far, what we have achieved is that x is equals to log with base 6 argument 3 over 8. So here we are going to use the change of base law. So I'm going to give some brief illustration about the change of base law over here. Okay, so basically, when you have log with base a argument b, and you want to change the base of the logarithm. So basically, the idea behind this is that if a, b, and c are positive numbers, if a, b, and c are positive numbers, and a is not equal to 1, and c is also not equal to 1, because a and c will become the bases over here of the logarithm. A is already the base. Okay, so here we have a basic condition. Okay, if a, b, and c are positive numbers and a is not equal to 1 and c is not equal to 1, so log with base a argument b is equals to, you introduce an other number apart from a and b. Okay, and let's say that number is c, and c is basically introduced as the base of the logarithm in the numerator as well and in the denominator as well. Okay, and in the numerator the argument will be b, and in the denominator argument will be a. This is basically the change of base law, and this particular change of base law is given to you in the formula booklet as well. Okay, if I just show you the booklet, in the booklet the expression is given in terms of x. Okay, here we have it. In the P2 formula booklet you have this change of base law formula given to you. Okay, in place of, you know b we have x, and in place of c we have b, which is exactly the same thing. So just for the sake of formality, I brought this screenshot from the booklet over here. Okay, so basically the idea behind this is that, according to the change of base law, as we have this thing right over here, that log with base 6 argument 3 over 8. Okay, so what we can do over here is that, we need to introduce the base as 2. We need to make base 2. So the number apart from 6 and 3 over 8, we can use it 2. So I can say that this is exactly the same thing as saying log with base 2 argument 3 over 8 divided by log with base 2 argument 6. Okay, this is the change of base law which we have applied over here. So you just need to pick up your calculator, and in your calculator first you write this complete expression log with base 6 argument 3 over 8. Come on, just write this whole thing in your calculator. So you are obtaining a value minus 0.547, correct to 3SF, okay? Minus 0.547. And now you write this complete expression in your calculator. You are going to get exactly the same thing. Okay, so log with base 2 argument 3 over 8, and whatever the value is upon log with base 2 argument 6. Okay, so you are going to get exactly the same outcome, which is minus 0.547, correct to three significant figures. Okay, exactly the same value. So this is basically the change of base law concept, which I have explained over here just for the sake of this recording, this video, just for the sake of formality. Otherwise, detailed concepts along with examples and questions is covered in my online classes with my enrolled students. Okay, so here we have applied the change of base law over here. So, in place of this expression log with base 6 argument 3 over 8, I'm going to rewrite it like this: log with base 2 argument 3 over 8 divided by log with base 2 argument 6. Okay, we are doing this because we need a specific form. Okay, so log with base 2 argument 3 minus log with base 2 argument 8. In the numerator, I have used the quotient law of logarithms. Okay, upon, in place of 6, I've mentioned 2 times 3 intentionally. Okay, because I need something in terms of a, because I need something in terms of log with the base 2 argument 3, and wherever I see log with base 2 argument 3, I will write a. Okay, so now here I have used the product law of the logarithms in the denominator. So this is now x is equals to, in the numerator, this expression is now log with base 2 argument 3 minus, log with base 2 argument 2 cubed. In place of 8, I have mentioned 2 cube. Okay, so now in the next step, I can use the power law, and wherever I see log with base 2 argument 3, I will write a over there. Okay, so a minus 3 times log with base 2 argument 2 divided by log with base 2 argument 2 plus a. And since log to its own base is equals to 1, so log with base 2 argument 2 is replaced with 1 in the very next step. So a minus 3 times 1 divided by 1 plus a, and therefore x is equals to a minus 3 divided by a plus 1 is your answer. Okay, so this was the alternative approach for doing this part 2. All right, so this was basically the complete solution of this question, October 2022, question number 10. All right, so now let's move on to the next question. So now up next, we have another question, which is October 2023, question number 5. Okay, so the question is saying that solve 3 raised to the power of a is equal to 70, giving the answer correct to 3 decimal places. Okay, so we have a straightforward index form. Okay, so I can say that 70 is equals to 3 raised to the power of a. It's easier to, just make a comparison that y is equals to a raised to the power of x. So a becomes the base of the logarithmic form. A is basically the base of the index form, which becomes the base of the logarithmic form. So log with base a argument y is equals to x. Okay, basically, this x in the power becomes a subject. So basically 3 is the base of the index form. This will become the base of the logarithmic form. So log with base 3 argument 70, this is equals to a, and therefore A is equals to 3.867. We need to give our answer correct to 3 dp over here. Okay, so straightforward, this working is enough to give you full 2 marks. Okay, so now in part 2, it is asked to find the exact value of b such that 4 plus 3 times log with base 3 argument b is equals to log with base 3 argument 5b. Okay, so here I have mentioned the working. So first of all, what I did, I actually, copied the equation, which is not important to do so. You can just start your working with this step. All right. So first I did, so first what I did, I kept this 4 over here on the left side and I collected the terms of the logarithms on the other side. Okay, and in place of 3 multiplied by log with base 3 argument b, according to the power law, this 3 will go in the power. Okay, so I can say that log with base 3 argument 5b minus log with base 3 argument b cube. So now I can use the quotient law of logarithms, okay, because we have a subtraction sign. So the argument can be mentioned as a quotient of the two terms. So 4 is equals to log with base 3 argument 5b divided by b cube, which will be simplified as 5 upon b square. So 4 is equals to log with base 3 argument 5 divided by b square. So I just, for the sake of formality, rearrange the equation in a basic logarithmic form, and then we convert this into a basic index form. So 5 upon b square will be equals to the base of the logarithmic form will become the base of the index form. So base will become 3 and the power will be 4 over here. So 5 upon b square is equals to 3 raised to the power of 4, and 3 raised to the power of 4 is basically 81. So 5 is equals to 81 b square, and b square is equals to 5 over 81. Taking square root on both sides, b is equals to plus minus under root of 5 over 81. But b should be positive over here, in order to make the logarithmic term acceptable. You know, the argument of the log should be positive. Okay, the basic property at any point, at anywhere, the basic property of the log is that, when you have something like this, let's say log with base a argument y is equals to x. So, the basic property of the logarithmic term to make it acceptable at any point, at any place, okay, this base should be positive, a should be positive, and a should not be equal to 1. Base should be positive and base should not be equal to 1, and argument should be positive. Y should be more than 0. This is the basic property which you always need to remember. Okay, the argument can be equals to 1, meaning this y can be equals to 1. That's not a problem. When argument is 1, basically, whatever the base of the log is, that whole outcome becomes 0. So in place of the argument, 0 is acceptable, but as far as the base is concerned, base is positive and base should not be equals to 1. This is the basic property which you always need to remember. So for this scenario, in this question, b should be positive as b is basically the argument of the logarithmic term. Okay, so this b should be positive over here, in order to make the logarithmic term defined. Okay, so in order to make it acceptable, or you can say in order to make it valid. Okay, so b should be positive, so log will be defined. So b is equals to positive square root of 5 over 81 will be acceptable only, and this value, the negative value, will be rejected. Okay, this is going to be rejected over here. So therefore b is equals to root 5 divided by 9, because under root of 81 is basically 9. So b is equals to root 5 over 9 is your only acceptable answer. So this was the requirement of this question. part 2, where we were required to find the exact value of b. All right. So for the sake of this video, I've discussed these two questions. This one was October 2023, question number 5, and the previous one was October 2022, question number 10. So I'll see you inshallah in my next video. Stay tuned to my channel. Thanks for watching. Assalamu alaikum.